Good evening. Thank you for joining us here at NASA's Kennedy Space Center in Florida for this STS-133 status briefing following the Mission Management Team meeting today. I'd like to introduce our panelists, Mike Moses, Chair of the Pre-Launch Mission Management Team.
Good evening.
And Mike Leinbach, Shuttle Launch Director.
Good evening.
I'd like to take just a few minutes to have our briefers speak. We're going to keep this briefing very short so that they can go home and get some sleep before tomorrow morning. Mr. Moses.
Thanks, Kendra. Well, we had our MMT today. We talked for a while, as we knew we would. It was basically the culmination of the teams working for the last 24 hours to pull together the story that we have with regards to this power anomaly we saw on the main engine controller. And again, just as a refresher, when we powered it up during a test yesterday morning, we saw an anomaly in the signature that was unusual. Basically, one of the phases of AC power, there's three phases on a alternating current circuit. One of those three did not engage, and the controller therefore did not power up. About an hour and a half, it kind of healed itself and started working. And then about another 2 hours after that, we saw a little voltage drop that didn't trip anything off, but was at the time an unexplained voltage drop. And that gave us pause. So we talked overnight, and the teams brought us a very good story today, a very nice cohesive flow through the data. We reviewed the history, the timeline of the events, other signatures that have occurred similar to this in the past. We talked a lot about our history and our knowledge of the circuit breakers, the components in the system, the switches, the wiring. We talked a lot about the main engine controllers themselves, their tolerance, their redundancy, and then ultimately went to a risk presentation of what do we know about the problem, what don't we know, and is that an acceptable condition to proceed with. At the end of the day, I'll kind of cut to the chase and say we wrapped up with a unanimous poll out of the MMT, no dissenting opinions, no requests for more data. Everybody was very comfortable with the story that came together today. And again, really the rationale there is that all evidence points to this being a circuit breaker problem, so a power supply feed problem. It's not a controller problem, so it's not a main engine controller. So no worries there that the main engine controller itself is going to have problems later on. From a power feed standpoint, really what we saw, and I'll kind of simplify it, but basically these circuit breakers are used in the orbiter. We use them as switches sometimes. You know, in your home, you don't use the circuit breaker as the switch to turn the lights on and off. You have a switch to do that. As a design and a weight savings feature, in some circuits, the circuit breaker is used as that switch. Sometimes it's because there's ways to send multiple power feeds to a given piece of equipment, and you don't want a switch to have all that power sitting right next to it. You use a circuit breaker to do that. Sometimes it's just more convenient and easier to save wiring to do that. So in many instances, and this is one of those instances, that circuit breaker is used as a switch. Now, there's also a switch used to turn it on and off. So these circuit breakers aren't cycled with power going to that circuit breaker, so they're not cycled hot. But what we've seen historically in the history of the program is these circuit breakers sometimes don't engage. When you push them in, you don't quite make that contact, and you don't quite get the connection. And we have a pre-approved contingency procedure, which we call basically scrubbing the breaker, and you pull it in and out 5 times, cycling it, and then you push it back in, you turn the power back on, and you see what you got. And in almost every single instance, that results in a good connection. And in fact, in every instance where we see a good connection, a good power feed connection, that connection then stays and lasts and does not give us any more troubles. We went through a lot of failure history. There were instances where we've had circuit breakers fail to engage. We scrub them, push them back in. They've engaged. We leave that circuit breaker in the ship. We don't take it out, and they've flown for 20 years with no reoccurrence of that problem that made it not quite engage the first time. And really what we went through is a lot of details. The act of using the circuit breaker as a switch can cause a little bit of buildup as there's some arcing and some current coming back and forth, and you get a little pitting, you get an uneven contact surface. The phenolic in there tends to get a little hot and melt, and you get a little non-metallic, non-conducting residue that builds up on these connectors. And by pushing them in and out, scrubbing them back and forth, you can knock that off. So what we think happened in this instance was that's the scenario we had. We had a little bit of residue built up on this circuit breaker. When we first pushed it in, it did not connect. And because of the sensitivity to the main engine controller, rather than immediately scrubbing that breaker, we sat and talked about it. While we were talking about it, the dielectric, basically the circuit breaker itself, the current, overcame the little bit of resistance that it was facing and the impedance that it was generating, and it made the connection and therefore sent power downstream to the controller, which powered itself up, and that resulted in the unexpected self-powering of the controller that we saw yesterday morning. Now, I say unexpected. That's really very well explained now that we understand what was going on. So it's not that something unknown was happening. The act of scrubbing it, we then went and scrubbed it. And when we put it back in, we looked at the high-speed data and found that second power-up after we did that first set of troubleshooting where we scrubbed the breaker showed a little bit slow response in the power-up as well. Not nearly enough to cause a problem, but it wasn't quite perfect. So further proof that we probably knocked some of that contamination off, but we didn't quite get it all. A little after that, we had this unexpected voltage drop. Again, very indicative of the fact that there's a little bit of resistance in there. We went through the data. I think I mentioned yesterday that about a 40 ohm resistance in this circuit in test. The theory, actually, the model shows that it only takes a 9 ohm resistance to cause the voltage drop we saw. So it just takes a minor little bit of contamination there to cause this signature. The other piece of data we found is this voltage drop is not as uncommon as we thought it was. It actually occurs not often, but a fair bit as the controller responds to the power on the input side. A fan kicking on, the controller itself drawing a little more current causes this voltage to kind of fluctuate just a little bit. The one we saw was a little higher magnitude than we've seen in the past, maybe a little longer duration, but it was still not the only time we've ever seen it, which is where we were yesterday. We thought this might have been an only time occurrence. So another big piece of data that got us comfortable today was the fact that it's not all that uncommon. And so again, when we laid it all out, it all racked up to be pretty clear that our most probable cause here is that we had contamination on that circuit breaker that we've slowly cleared off by scrubbing it. In fact, after we left last night, after we left the press conference last night, we scrubbed it 5 more times. Those power-up signatures were perfect, just like they've been in the past. So pretty good proof that we've knocked the contamination off. Our history shows us that once we do that, that is a solid connection and it's not going to change. And therefore, we had pretty good acceptance rationale today to go fly. And so, again, we kind of went through all the ins and outs. We talked about what if we're wrong. We talked about all the things that could be bad. And at the end of the day, while we don't completely understand the failure because we don't have it sitting in front of us as a failed component, everybody was comfortable with the residual risk left, that it was an acceptable one to take. And we do understand that anomaly that we had. And, again, we're good to fly. So that takes us to the schedule, and just try to cut off some of the questions. Right, the weather still looks really bad for tomorrow, but we're going to go ahead and go down to the Tanking Telecon in the morning. Basically, at 5:30 in the morning, the team's going to get together, and we'll talk about what the latest forecast is. We'll see what that is. If the forecast tomorrow morning is still as bad as it is today, there's a chance we might decide not to spend one of our opportunities tomorrow. But it's not. It's too early to make that call right now. We need to see what the forecast is. 12 hours out, it's a whole lot better forecast 12 hours out than it is 24 out, especially when that front's not quite moving as much as we maybe thought it was. That might be a good thing, it might be a bad thing, but we'll know better in the morning what that really means to us. So gave Mike and his team the challenge to go have us ready to go, and with the caveat still that, as always, the weather might make us make a different course of action. But from the vehicle perspective and the mission management team, we're ready to go, and at this point kind of turn the reins over here to the launch team and execute launch for Discovery.
Okay. Thanks, Mike. We'll see the team in the firing room is doing really well. The additional hole we added to the countdown presents no problem to us at all. We recycled some mid-deck experiments to refresh them, so essentially when we get into countdown tomorrow, we'll be in a first launch countdown posture. We wanted to rotate the rotating service structure to the park position tonight at about 6:30, and we got held up because of Phase 1 lightning concern in the area. So we're on hold for the RSS. Right now, that's not a big concern for us. Talking to the range weather before I came into this briefing, Kathy Winters expects that to last an hour, maybe an hour and a half or so, and we should be able to get the RSS retracted in about an hour, and that's no issue for us. The rest of the countdown is very, very nominal for us. We're looking for the opening of the launch window at 15:24 tomorrow afternoon, Eastern Time. Team's in great shape, ready to execute. I just might add to the mission management team discussion, from my perspective, it sounded very, very good. The flight rationale is solid. Scrubbing off circuit breakers is something we do, very, very standard process here at KSC. We have a procedure to do that. So it really, truly sounds like we've got the culprit and we've cleaned it off and we should be good to go. So team's ready to execute, and we'll come in the morning and see if the weather permits a tanking and a launch attempt tomorrow. Thanks.
Thank you. We have time for just a few questions. When the microphone comes your way, state your name, affiliation, to whom you're addressing your question. We'll start over here with Bill.
Bill Harwood, CBS News for either one of you. You guys were talking yesterday about not overstressing the launch team. And I'm just curious, with the forecast being what it is and the fact that these guys have been working pretty hard over the last day to generate all this data, give you guys this presentation, and then go home and come back in a couple of hours to tank with a pretty bad outlook. Why not wave off a day right now?
Well, we talked to the team that put together all the charts today, and really the team that's going to come in tomorrow morning and fuel the vehicles is a different team. Now, there are some people that were at the presentation all day long today and have to cycle back in tomorrow morning, but it's just a handful of folks, and so that's not an issue. We also asked if the team would be prepared for 3 in a row, if that should become necessary, if we don't tank tomorrow for whatever reason, and wave that off, would we be able to go 3 in a row? And given the 1 day additional time in the countdown, people cycled back. We were essentially in a babysitting mode in the firing room, so everybody got a good day off. We made sure that everybody is working to our work rules that we have in place. So right now, I don't see an issue with tomorrow, certainly. And even if we get into a 3 in a row scenario, we always ask the team before that third attempt if they're ready to go, and we would do that again, of course. But the pre-planning for that says we should be fine.
James Dean from Florida Today. So is 3 in a row what you expect you would attempt? Well, depending on what happens tomorrow.
It depends, right?
It's early to say
yeah.
that.
What is your latest on your last possible launch option
we're talking about the window and extending the window out. I mentioned that a couple times. Right now, it looks like there's potential there to make that happen, but some of the hurdles are pretty big, and so right now the posture is that we're not going to pursue that. And again, I say that, and then we always have the caveat that we might find a way to make it work. But right now, it looks like the 7th is still our last launch attempt.
Marcia?
Marcia Dunn, Associated Press, and my questions have been asked, but I'll come up with something here. We've been reminiscing for the last week about Discovery's last launch. Mike, yesterday you said that, she doesn't want to go out quietly or easily. Any mention of that today, or any new reflection on any of that?
No, there was no talk in the briefing today about Discovery's last flight. It was all about the anomaly and do we understand it, and are we safe to fly? And the answer to that is yes. So no, there was no reflection to that meeting at all.
Greg Dobbs with HDNet Television. Can you give us a picture, if you can give us a picture of the scrubbing? What does this actually mean? I mean, I'm picturing a switch going in and out, and the residue gets pushed off by the female in the male-female relationship.
It's actually it's a metal-to-metal contact. So there's the passive part of the circuit breaker is 2 flat metal plates, and then the active part, the plunger that moves in and out, has 2 concave mating surfaces on it. So you're literally pushing those 2 metal contacts together and then pulling them back apart. So the act of pushing them in and the mechanical force of doing that knocks any debris that's built up on that metallic contact off.
That was the fix.
Yes.
Mark?
Hi, Mark Kirkman, Interspace News. Some of us were out of the pad, so we missed part of your briefing. If you covered it, or if not, could you explain what you'll do if I know you don't expect to see a reoccurrence, but if you do see the same transit, even though it's within limits, what's the plan during the count if you see that again?
We talked about that. No, we didn't. We talked that a little bit. The team has talked that. We didn't bring it up at the MMT too much, but basically the plan would be we'd talk about it. The thing that we discussed today that was kind of the new data we didn't have from yesterday is that these momentary voltage dips of a couple volts on this composite voltage at the controller itself are not as uncommon as we thought they were, and that they're actually not regular, but they can be tied to an event in the AC feed upstream, or they can be tied to a controller issue itself. So from that standpoint, seeing another little anomaly of a current or a voltage drop-off might not be a reason to pause. We are most certainly going to talk about it and make sure we understand it, that it doesn't violate any of the understanding we have as we go into this anomaly, and that nothing in those conditions have changed. But it's not an automatic punt and run with your hair on fire. We're going to talk through it just like we would any other problem. So we did get a little further today to understand, again, the concept of what the signature likely is. Now, if we saw something that showed us that this contact is degrading and that the connection that the circuit breaker is making is now becoming no longer a valid, solid connection, that would violate what we kind of used as our rationale today, and we would most certainly stop and talk about that.
That's all the time we have for the STS-133 status briefing. Launch coverage will begin tomorrow morning at 6 a.m. Eastern Time, live on NASA television with the beginning of tanking. For more information on the STS-133 mission and crew, please visit www.nasa.gov/shuttle. Thank you.